Hello guys, welcome back, and now we will do the remaining part of the Great MDP game. The remaining part was all about to get the reward. We are seeing that we have not received the reward till now. So first of all we will define a function that will taking the reward. Like first of all we are saying that the living reward equals to 0. And now we have to make the object of the MDP class. Objects, let's say MDP1. The class was Great MDP. Then we will define the living reward. This copy. Plus run it. Minus run it. We have defined the reward and the remaining was terminal state. Terminal state. It's saying here we have done some mistake. Here the bracket. That was the bracket mistake just. Now we have defined the terminals as well as the reward. Now if we want to print the states only, so we can print the states here. Object which we have defined, and we want now the states. This will give you all the state of the grid. It has given all the states of the grid. Now if we want to action, like we want to print that for a in mdp1 dot action. Action we have to give without terminal, because at terminal it will give you none reward, none. And action at state, let's say we are defining this state. it will return you all the actions at this state. Now for terminal, we have said that it should return us the terminal states for 3.2 and 3.1. So if we will give here 3.2, so it should return us none, because that's the terminal state. Now we are saying that here the basic time iteration we are talking about. Iteration we are doing like k equals to 1, 2, and we are saying that whenever we have a terminal state, if we have just the terminal state, so what it should return? It should return a 0, and it had returned a 0. But if the state is not terminal, then what we have to do, this is not terminal, just you have to add the discount, multiply the discount with terminal state, plus you have to add the reward, and with all this you have to add the transition function and then sum up. We have talked about that if the state is the terminal state, then just return us the terminal state with the reward. But if it is not the terminal state, what it have to do, the decay factor, which is basically the discount, it have to multiply it with the state, and we add the reward. With the reward, it have to add a transition function and then sum up the whole. So we have to define the probability we have defined. Now we are talking about time iteration. So for time iteration, we have to define a function now we have if we are talking about state S is 0 for state in MDP1.state,